Hello to all my dear students. Today I'm going to solve the exercise NCERT exercise of chapter number 13, that is light. The lecture is already given in the playlist. Now this is the exercise solution. So let's start. Number 1. Suppose you are in a dark room. Can you see objects in the room? Can you see objects outside the room? Explain. Now, how do we see objects? We can see any objects when light is reflected by that object and then it reaches our eye. How do you see? First, you need to understand how do you see anything. So, when we can see, we can see any object when light is reflected by that object. Reaches when light reflected by that object reaches to our eyes. Okay, no need for the is. All right, so this is the main fundamental of our sight, why we see objects. So now if you are in a dark room, can you see objects in the dark room? In the dark room, can light be reflected back by the object? No. So we cannot see objects in a dark room. In a dark room, no light is reflected. By the object. So, therefore, hence we cannot see in a dark room. Hence, we are unable to see in a dark room. Okay. Now, next question is, can you see objects outside the room? Yes, if there is light outside the room, we can see objects outside the room. If there is light outside the room, we can see objects outside the room. Clear to everyone? Okay, so the first question is done. The next question. Differentiate between regular and diffused reflection. Does diffused reflection mean the failure of the laws of reflection? So let us first differentiate between a regular reflection and diffused reflection. So, can you all see the black screen? Let us make a column for regular reflection and diffused reflection. Like this. Okay. So we'll have regular reflection in the first column and diffused reflection in the next column. Okay. So firstly, regular reflection. It takes place from a smooth, polished surface. It takes place from a smooth, polished surface. Okay, whereas diffused reflection, it takes place from a rough surface. It takes place from a rough surface. This should be our first point of difference. So yes, number one. Number two, reflected rays moves in a particular direction. All reflected rays moves in a particular direction. Or you can say they are parallel. The reflected rays are parallel. All right. Whereas in diffused reflection, the reflected rays are scattered in random directions. All reflected rays are scattered in random direction. Okay. Third point difference can be example. So example will be reflection by plane mirror. By plane mirror. Okay. Here also give an example. Example, reflection by anything you can write. Suppose for a road surface or a book, reflection by a book, table, etc. Any object around you. Along with these three differences, you can also draw a ray diagram. So let me show how you will draw a ray diagram for regular reflection and diffuse reflection. So let me first write down the heading, regular reflection, diffused reflection. Okay, so let us draw a ray diagram for regular reflection. For regular reflection, as we stated, uh, it is a reflection that takes place from a smooth, highly polished surface. So what is an example of a smooth, highly polished surface? A mirror. So we have taken a mirror over here. Okay, now we will take multiple incident rays. Suppose 1, 2, 3. You can take as many as you want. I've taken 3 parallel rays. Whenever you're drawing an incident ray, make sure you draw the arrows. Again, the reflected rays, as we know, will be in a particular direction parallel to each other. So all of them will be parallel to each other. So this is an example of regular reflection. Now let us see how can we show a ray diagram for diffused reflection. So for a diffused reflection, we are going to take a surface with irregularities. That is a rough surface like this. And then we will take incident rays that are parallel. So let us take again 3 parallel incident rays. 1, 2, 3. And as we know that in diffused reflection, the reflected rays are scattered in random direction. So because of the irregularities, they will be scattered in random directions. Something like this. You can clearly see they are not parallel to each other. Okay. So going back to our question. Now, the second part of the question says, does diffuse reflection means failure of the laws of reflection? No. in both, whatever reflection taking place, whether it is a regular reflection or an irregular reflection, they both obey the laws of reflection. So there is no failure of laws of reflection. Question number 3. Mention against each of the following whether regular or diffused refraction will take place when a beam of light strikes the surface. Justify your answer in each case. Okay. So the first one is a polished wooden table. So a polished wooden table is an example of smooth surface because you see it's polished. If it was a simple wooden table, then it was an example of a rough surface. But here it is a polished wooden table. So if it's a polished wooden table, it is an example of a smooth surface. So when a beam of light reflects from it, it will be a regular reflection. Okay. The second one is chalk powder. Chalk powder has irregular surface. So what kind of reflection is going to take place from here? Diffused reflection. And for reason, they want you to justify the answer, just write down because it is an irregular surface. It has irregularities or it is a rough surface. Okay. Second is a cardboard surface. Again, cardboard surface is also an irregular surface. So what kind of reflection is going to take place from a cardboard surface? Diffused or irregular reflection. Okay. Then we have marble floor with water spread over it. Now, when marble floor has water spread over it, it provides a smooth surface, right? So what kind of reflection is going to take place? Regular reflection. Okay. Mirror, obviously, we all know it's a smooth, highly polished surface. So regular reflection. Piece of paper again is a rough surface. So diffused reflection. Okay. Now, question number 4. That is state the laws of reflection. So there are two laws of reflection. Let us quickly see. Laws of reflection. First one you can write down. The incident ray, the normal at the point of incidence, and the reflected ray all lie on the same plane. So this is one of the laws of reflection, and another law of reflection is angle of incidence is equal to angle of reflection. Okay, we all know these two laws. We have also discussed it while we were studying the chapter. If you have any problem understanding, you can go and see my video lecture. Okay. Now, question number 5. Describe an activity to show that the incident ray, the reflected ray, and the normal all lie at the same point. Okay, on the same plane. So there is an activity in your book. You can just go through that activity and you can you can write down that activity from the NCERT book. All right. Now, question number 6 is fill in the blanks. 6A. A person 1 meter in front of a plane mirror seems to be dash meter away from his image. So, we know that if a person stands in front of a mirror, Suppose there is an object in front of a mirror is at 1 meter. So the image will also be formed 1 meter behind the mirror. So the distance between the object and the image will be how much? 1 meter plus 1 meter, 2 meter, right? So the answer will be 2 meter over here. Number B. If you touch your dash ear with right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched with dash. So this is the concept of lateral inversion. We discussed in our lecture lateral inversion. What happens in lateral inversion? The left appears right and the right appears left, right? So if you touch your left ear with the right hand, in front of a plane mirror, it will seen in the mirror that your right ear is touched with the left hand. Okay. The size of the pupil becomes dash when you see in the dim light. In dim light, the size of the pupil becomes large. In bright light, the size of the pupil becomes small. Okay. Number D. Night birds have dash cones than rods in their eyes. Now, night birds, they have less cones. Okay. Now, question number 7. Angle of incidence is equal to the angle of reflection. Always, sometimes, never, under special conditions. This law will obey always, whether it is diffuse reflection or regular reflection. So answer will be 7A. Question number 8. Image formed by a plane mirror is, now when I have talked about the properties of image formed by a plane mirror, so whenever an image is formed by a plane mirror, it is virtual in nature. Okay, it is behind the mirror, right? And it is of the same size as the object. So which of the option is matching over here? Virtual, A, B, both are virtual. Behind the mirror, A, B, both are behind the mirror. But about the size, in A, it is enlarged. In B, it is same size as the object. So answer will be 8B. Okay. Question number 9. Describe the construction of a kaleidoscope. The description, it's a long one. The description, how do we construct a kaleidoscope? I have already discussed in my lecture. So you can go through that and you can also see the NCERT for the description. It's given very nicely over there. Okay. Still, if you want any help, you can mention in the comment section. I'll write the description for you. Draw a labeled sketch of a human eye. Again, it's there in your book. The questions I'm marking NCERT, you can just check, and still if you have trouble, please put it in the comment section. I will help you out with that. Question number 11. Gurmeet wanted to perform an activity 13.8 using a laser torch. Her teacher advised her not to do so. Can you explain why? See, this I have discussed before also. Intensity of laser beam is very high. So it carries a large amount of energy and it is harmful for eyes and can cause permanent damage. So one should not look at laser beam directly or indirectly for a longer period of time. Okay. Question number 12. Explain how you can take care of your eyes. So there are a list of things that you should do to take care of your eyes. Let us see that. How we can take care of our eyes. Number 1. It is advised we should use suitable spectacles for troubled eyes. Question number 2. Too little or too much light is bad for eyes. Too little or too much light is bad for eyes. So when you are studying, you should do it in sufficient amount of light. Okay. So insufficient light causes eye strain and headache. Insufficient light causes eye strain and headache. If there is too little light, it can cause eye strain and headache. And if there is too much light, like that of a sun, then it can injure the retina. Too much light can injure the retina. So make sure there's sufficient light, neither too little nor too less. Okay, we should not look at the sun directly. We should not look at the sun or laser light, because that's also powerful, directly, because that can damage our retina. Okay, never rub your eyes. Never rub your eyes. If you feel that something has gone into your eyes, or if you're having an itchy eye, just splash some water. Okay, if dust particle goes into your eyes, wash it with clean water. Okay, always read at a normal distance of distinct vision. Do not read by bringing your book too close to your eyes or keeping it too far. Okay, always read at the normal distance of distinct vision. Do not read by bringing the book too close or keeping it too far from your eye. So these are some of the advices, some of the suggestion how you can take care of your eyes. There are many more you can check. All right, let's go back to our question. Question number 13 done. Question number 12 done. Question number 13. What is the angle of incidence of a ray if the reflected ray is at an angle 90° to the incident ray? Okay, let us draw a ray diagram for this figure. They are asking about the angle of the incidence ray if the reflected ray is at an angle of 90° with the incident ray. That means the angle between the incident ray and the reflected ray is 90°. So if we draw a diagram something like this, suppose this is the mirror. Okay, this is the normal. Suppose this is the incident ray, this is the reflected ray. Suppose they are making an angle of 90°. So we know according to the laws of reflection, angle of incidence will be equal to angle of reflection, right? So in that case, if the total is 90, they will be 90 divided by 2, that is 45°, 45°. So what will be the angle of incidence in this case? It will be 45°. Okay. Question number 40. How many images of a candle will be formed if it is placed between two plane mirrors separated by 40 centimeter? All right. So how will you find this? Just see how they are placed. They are placed parallel. So whatever the distance they are separated, if they are parallel to each other, that means the number of images will be infinite. So infinite or infinity. Okay. Do you all remember the formula I taught you for number of images? It is how much? How do we do? 360 divided by theta minus 1. In this case, theta is 0 degree because they are placed parallelly. So anything if you divide by 0, the answer is undefined or infinity. All right. So number 14 done. Number 15. Two mirrors meet at right angles. A ray of light is incident at one at an angle of 30 degree as shown in this. Draw the reflected ray from the second mirror. So since it's a mirror, we all know that the reflected light ray will also be at an angle of 30 degrees. So suppose something like this. Okay. So this is also 30 degree. Now this light falls on another mirror. So here again we'll draw a normal. Okay. Now since this is 30 degree, this will be 60. If this is 60, this is 90, this will be 30. That means here the angle of incidence will be 60 degree. Okay. So now the reflected ray will be at an angle 60 degree according to the laws of reflection. Okay. Is it clear to all of you? So number 15 also done. Let us come to question number 60. Here you see Bujo stands at A just on the side of a plane mirror as shown in this figure. It's shown in a figure. Can he see himself in the mirror? Also, can he see the image of objects at P, Q and R? Okay, now see, you see that Bujo, he is standing away from the mirror. He's not in front of the mirror. So obviously he can't see his own image in the mirror. Okay, as light will not be incident and reflected from him because he's away from the mirror. He's not standing in front of the mirror. So he can't see his own image. The answer to the first question is he can't see his own image. And why he can't see his own image? Because he is not standing in front of the mirror. Now, also the second part of the question says, also can he see the image of objects P, Q and R? So you see P, Q, P is over here, Q is over here and R is over here. So he is able to see objects at P and Q because the rays are coming from P and Q and they are getting reflected by the mirror and reaching his eyes. The ray from R does not reflect and reaches Bojo, so he cannot see the object R. So for that, you can draw a ray diagram and see if the rays are reaching eyes of Bojo or not. Okay, so just draw a ray diagram. Suppose we have an incident ray coming from P and then a reflected ray reaching Bojo like this. Okay, so obviously you can see the image of P. Okay, so similarly, we can also draw a ray diagram for Q. You can see also this reflected rays are reaching to Bujo, so he can see Q. But for R, it is not possible. Okay, R is too far away. All right. Number 17. Find out the position of the image of an object situated at A in the plane mirror. So here, this is the object A. You have to find the position of that object A. How will you find the position? By drawing a ray diagram. So the image of the object at position A will be formed behind the mirror at the same distance away from the mirror as the object is, because we know, right? If you stand in front of a mirror, you see your image in the mirror. And how far do you see your image? Exactly how much you are in front of the mirror, the image will be formed exactly the same distance behind the mirror. And do you see yourself big, small, or of the same size? Same size. So it will be of the same size. So suppose at the same distance and same size. Here you see the object of the image A, the image of the object A. Now, can Paheli at B, Paheli standing at B, see this image? Yes, Paheli at B can see the image because the rays are getting reflected from A will reach B. Okay, so yes. Number C. Can Bujo see this image? Bujo can also see the image because his eyes are reflecting the rays from A. Alright. Next, D. When Paheli moves from B to C, where does the image A move? See, if we trace the reflected rays from B and C backwards, they converge at a point behind the mirror. Position of image remains fixed even if Paheli moves from B to C, because A is not moving. It is right there. So wherever Paheli is moving, whether she is moving to B or C or some other position, the distance, the image will not move. It will remain there as it is. Okay. You can draw a ray diagram over here. You can take incident rays from A like this, and the reflected ray like this, reaching Paheli and Bujo somewhat like this. See, because I don't have scale over here, so my rays are a bit tilted, but you guys please use scale and pencil to draw the ray diagrams, and also make sure that the angle of incidence is equal to angle of reflection when you draw a ray diagram. Okay, clear? So that's all for today. If you face any problem, any difficulty, you're always welcome to mention it in the comment section. I'll be helping you out with it. Thank you and take care.